Good evening. Cool. Laser, a mirror. Might put a balloon over it when you get all of the well, don't they say frequency, isn't it? Everything frequency, and it's sort of a bit of fun. Pick up some vibrations. Anyway, funny old week, nasty week, very nasty week. In fact, I call it one of the nastiest weeks I've ever had. Lost somebody very precious to me here in Australia, dead, gone. And then last night I watched one of my bestest ever friends, his funeral in the UK from Video Link. Catch you later, Graham. We'll see you on the flip side, like we always used to say. Haven't spoken to him in years, but sometimes, came as a shock. I find it hard to motivate myself. Really am. Spark's missing. I've got to push through a missing spark, of all things. Now, we know during a solar eclipse, it is a fact of life, a fact of everything, right? The sun's light is absolute. Boom! When it's on everywhere at the same time. If it's switched off, there is no light without a source. So if the sun did switch off, it would go black immediately. We're not going to have a wave of light, the last wave of light after the sun turned off, coming towards us. It's ridiculous. As soon as the sun went out, it would just go black. When it turned on, it will light everything up again. Same as a light bulb does. Exactly the same. Bang! If it's on, it's on. If you're looking at it, you'd see it immediately. 8 minutes and 20 seconds. Now, I'm getting addicted to these photon things.
You've probably noticed that now in many big cities at night time, everything is quite visible as during the day. But the evolution of the devices that give light to humanity hasn't affected its physical properties in any way. The basis of the phenomenon is still specific elementary particles, photons. They transmit all kinds of radiation, including visible light. So, thanks to these particles, we observe distant stars and galaxies, as well as light up our houses. To demonstrate the photon's property, you need to go to deep space. Its vacuum is a pure heaven for these tiny particles. There they can cover millions and billions of light.
That doesn't look like Mickey Mouse, does it?
And it had frog head.
It's a Mickey Mouse, okay?
Whatever their story. Reach for the 3D ripples of Australia's fastest absorbing paper towel.
It's unbelievable.
Alright, I don't do mice, alright?
We've got our trading account, we've got
do everything.
investment account, we've got a number of term deposit accounts, and we've got
Distances without colliding with anything. So, what are the characteristics of photons?
Photons.
The photon has no mass and no energy. They don't have dimensions and are able to move at boundary speeds. In particular, in a vacuum, they cover 300,000 kilometers distance per second. But in a transparent environment, photons are much slower. For example, getting from the solar core to the corona will take the particle about 1 million years, while at the same time it will reach the Earth in 8 minutes as soon as it gets into outer space. The photon is the most common particle in the macrocosm. There are 20 billion photons per proton or neutron. There is no time for them, as these particles are almost eternal, but the photon's life lasts for an instant. It lights up and immediately gets absorbed. Many people wonder where photons go when a star dies, a galaxy goes out, or a light bulb turns off. For example, the light emitted by the ancient stars when they still existed reached human eyes only billions of years later. That means that now we see the light.
Yeah, where do photons go? It's a bit tricky. I
The
haven't heard this
stars
one.
that are most likely long dead. But the sun, as you know, dies long and spectacular, just as you also know that an ordinary light bulb turns off quite simple. You click the switch and the room goes black. But where do the photons that the lighting device emitted fractions of milliseconds ago disappear? Let's turn to science. At the moment, when you turn on an incandescent lamp, or any other kind of it, it begins to spread millions of photons randomly moving around. According to the law of physics, after that, particles have two options: either be reflected or to be absorbed by other objects. Thanks to the first phenomenon, we are able to see objects around us and see ourselves in the mirror. It's important to understand that when reflecting, that is, colliding with an object, photons lose some of their energy potential. But during absorption,
Indestructible.
the surface usually gets heated as it absorbs some of the particles. In practice, this appears as follows: warm park benches in summer, hot pebbles on the beach, hot stones in the desert. The process that occurs after the lamp is turned on is based on these phenomena. Photon streams are reflected from other objects or eventually absorbed by them. When we turn off the light bulb, new photons stop entering the room and the old ones don't disappear. They continue to collide until each particle finds an atom that will, roughly speaking, eat it. You may come up with a reasonable question. Why does the light not go out gradually if the remaining quanta are still in the room? If you think about it a little, you will come up with the answer by yourself. For photons, the concept of some time is equal to what is an instant for humans. The fact is that unique particles are reflected and absorbed in millionths of a second, so we just cannot grasp the...
There's your millionths of something again.
true moment.
Millionth of a second?
For the observer, there are only two states, before and after pressing the button. Photons, on the other hand, experience a whole adventure during this time, but quanta of light surround us not only when we light a chandelier or a
Look, honestly, all of it. All of it. This right here contradicts everything that they're saying on that TV right now. Everything that is ever said about photons. Look, Earth, Moon, Sun, direct line when somebody's in the sweet spot. This can only happen if the sun's light is absolute. There is no way around this. Right? So, look, I'm going to leave it there for tonight. I will be back. I'm having trouble getting into it. I will be back. I will be back. It's been one of those days. Couple of days. Laters.